Alright, so today I'm going to be going over one of the most miserable, most bullshit repairs that there is on a MacBook motherboard, which is replacing the SMC. There are many things that make this bullshit, and we're going to be going over them in real time. So one of the reasons that I haven't done one of these videos is because most of the time that I have a board that needs SMC replacement, it looks something like this. Like, yeah, I mean, there is a damn good chance that there are other things wrong with this board, but usually when you have a board that needs an SMC replacement, it's just fucked to the point of like everything being destroyed, which is, you know, again, very much so against my 20-minute rule. So I've already removed the SMC from this board. I'm not going to be able to show you that part of the process. But you are going to see me take the SMC off of a donor board, take that SMC from the donor board and put it on this board, and we're going to see what happens. So the first reason that this process is a complete pile of horseshit is that I cannot get new SMCs. I can get new SMCs with no programming, sure, but what fucking good is that going to do me? I need to take SMCs that have programming already on them. I have no way of programming this SMC with the original firmware, so what I have to do is I have to take boards that look like this, that have holes in them, that very well may have been destroyed because of a bad SMC, and take the SMC off of this piece of shit to put it on here. So let's start with that part of the process. Again, this completely sucks because I don't know if this SMC I'm removing even works. I'm going to go through a lot of trouble, a lot of misery to get this SMC off of here, and again, this SMC may actually be a complete pile of shit. Who knows? But that is what it's like to service Apple products as a third-party repair center. Hell, if we can be allowed to program this, hell, if they're going to give us any information on how to do it. Because there is information, there are connectors on the board where you can simply plug something in here and just program it, but are we going to get that information, that software, that support? No way in hell. Apple would never want people to know how to actually service their own products. That would be oh, dare, no. We have to do this bullshit. And that's the thing, like, you're not stopping people from fixing this stuff. A 26-year-old college dropout who can barely pass a CPR AED exam is still going to be doing this shit and filming it and putting it up on the internet for people to see so that they can do it themselves as well. Like, you're not stopping people from doing anything. All you're doing is making it more of a pain in the ass, and you're causing more people to hate you. So the other reason I haven't done one of these videos again, A, that board, it may not work for many other reasons other than the SMC. And also, I don't know if the SMC I'm even putting on it is good. And I like to show you that what I did worked. I like to show you that the result of my work is a product that works. I always tell you, if somebody cannot show you that the product works, that there's no reason to listen to them, because they're showing you how to do something that just doesn't work. But here, I'm just going to break that rule. Because there's no video on the internet that even shows you how to remove an SMC, how to reball an SMC, how to do any of this stuff. And that actually goes through it in depth and detail. There's none at all that even show you without the depth and the detail. You can't even find an SMC replacement video where they're doing it with techno music. So I'm going to do it, and even if it doesn't work, again, troll's going to troll. You can laugh as much as you want, but it is what it is. Also, most of the time that this doesn't end well, and the boards that I do this on are usually boards that are completely fucked, and the boards I'm taking the SMCs from look something like this. Okay, got the SMC off. Now the first thing to do is to clean this thing. So I'm going to take this clamp that I got over here. This is my clamp. And we're going to put the SMC inside of the clamp. Now what I want to do is I want to clean it. So I have this clamp that's actually kind of made for this size chip. I'm pretty certain that I got this from David at Advanced Reworks. I'm 99.999% certain that this came from David. So if you need one of these things, hit David at Advanced Reworks up and ask him for one of these. I just got flux on me. Blah. Alright, so I'm going to wash my hands to get that shit off of my fingers. And before I do that, you can take a nice look at what this looks like. Pretty, isn't it? Friggin' flux. Ugh. So the first thing that I want to do is I want to wick the solder off of the pads. But what I want to do is I want to make sure there's no lead-free solder on there, and also that there's none of that oxidating, junky, nasty bullshit on there that's going to keep the pads from being able to be tinned. So what I'm going to do is I'm going to actually try to tin every pad right now with my leaded solder over here. And I'm going to show you, I'm going to talk about what I'm looking for as I go. This looks like some dry, gunked, caked up crap. Come on, get hot. Just turned on the Hakko. Okay, it's hot. So what I want to see is that I can get solder to stick to every single pad. So first I'm just going to make a quick walkthrough to get rid of any of the lead-free junk. Now it may look like the pads that are ripped. That's the first thing that you're going to think of if you're not used to working on stuff at the scale. But what you're going to see is if I scrape a little bit, you're going to see that the pads get tinned. So I'm going to focus a little bit on each pad. So for example, the one all the way on the upper left. Looks like a ripped pad, right? I'm not going to scrape hard, because if I scrape hard I destroy it. But I scrape a little bit and then I solder. And the one under it. Scrape a little, then solder. Scrape a little, then solder. So what I want to do is I want to make sure that every single one of those pads is prepared to accept the balls that I'm going to be putting on it. Because there's no point to reballing this chip if the pads don't accept the solder, because they're just junk, and you know, so a little bit. And I clean it with this because the iron itself is hot. So the iron being hot is, you know, it's going to be better for removing dirt than if it's cold. It's a piece of metal that I can scrape with. I have good control over it. I'm used to using this, so I know how much pressure I'm putting, because it's an instrument that I use all the time, every day. So I'm just going to go through here and just kind of try to make all those pads work again. The other thing is this solder has flux inside of it, so flux is also good at getting rid of oxides and dirt and other junk. So what I want is, as I'm scratching that stuff away, I don't want it to just go back onto the pad. I want it to get sucked up into that solder ball that I'm making, and then I just wick it off of the iron, and I clean it off of the iron, and so I have a solder ball that's probably filled with old flux and dirt, and I just wash that away. Okay, gonna go. So this is not actually putting balls on it. All I'm doing is tinning the pads, because I want to know that each individual pad has the ability to accept solder. This is an important part of the process. This is not very important with graphics chips that have large pads, or CPUs with 0.75mm balls like the old Core 2 Duo ones. But with the SMC it is, because, I don't know, this chip is just designed to be a bitch. There's no other way to put it. This chip is a female dog. A very loud, barking, obnoxious female dog of chips. We just go through, we go through. After a while, that rosin flux gets nasty, so eventually I am going to have to clean it off. I like to try to get this done before doing a cleaning, just to stay kind of efficient with it. There's one pad that's not tinning. Here we go. I'm getting somewhere. Okay, so that pad I was very close to just saying that it's ripped. Let me just grab another board and get another SMC, but I was able to scrape away at it. It wasn't ripped. Again, you're going to think that a lot of these pads are ripped. They're not ripped. They're just really, really fucking dirty. So keep that in mind. So at this point, I've proven that just about every single one of these pads can accept solder. And since I've done that, now I'm happy that I can go ahead and clean. So let's just wipe that junk off, some alcohol and this, and before I do that I'm going to heat it up a little, just so that the flux comes off easy. Because it's easier, I guess. Yeah, that stuff comes up a lot easier when it's hot. So I heat the flux up with the hot air. And it just gets away from my chip, which is very nice of it. Now what I'm going to do is I'm going to remove the that leaded solder that I just put on there. I'm going to apply some flux. I'm going to do it in a really bad way by using tweezers because I lost my syringe, which I usually use for this in my... This is some Amtech 559 right here. Now the Goot wick that I use actually has some flux inside of it, but it's not really as good as this stuff. And this is going to help me get rid of all the solder that I use to tin it. I want the pins to be flat. In this case, I really do want the pins to be as flat as humanly... The pads, not the pins. I'm losing my mind. I want the pins to be flat. It's going to give me less of a chance of it being a nightmare to resolder the chip. Okay. Now I'm not using the flat iron for this because having the elbow that I can on this curved tip actually makes life a little bit easier for me. So I'm going to cut off some fresh wick. Keep in mind, all this work I'm doing on a chip where I don't even know if it's good. That is why SMCs are such a fucking waste of time. I have no idea if the SMC I'm using is good. This is not a chip from Mouser. This is not a chip from DigiKey. This is a chip I pulled off a board that I bought on Alibaba with a hole in it. Usually I use the flat tip for any type of wicking, but here I'm using this tip for the wicking instead because it's easier to get into these little creases, and because you can't really see it from here, but this is kind of like underfillish like material that's around all the pads. So it's not like the pads are just there and you can just easily get to it with the flat tip. You really kind of have to dig in there to get this shit out. And this tip does a good job of that. Also, one of the things to realize is you're not going to get it to be perfectly flat, so just fucking give up on that idea. You will rip every single pad on this SMC trying to get it perfectly flat. Don't bother. I'm sure that there are people out there that just to troll me will try to figure out a way to get it perfectly flat. And if you can, that's great. You wasted hours of your time on something that is totally inconsequential. There are some chips where you need to get absolutely perfectly flat, and this is not one of them. This is one of those chips you just pray and you thank God the moment that you have something that's remotely close to flat. Just going over it again. And eventually you're just going to have to accept that that's the best that you're going to do. So here I'm pretty much close to that point. Because you don't want to scrape, or you won't want to break the first layer and destroy the traces or destroy the pads just because you were this OCD lunatic that wanted it to be perfectly flat. So don't do that to yourself. So, yeah. Okay, we're going to get another ESD safe paper towel here. I got to get a better way to set up this mic so it stays by my mouth. Alright. Okay, and clean. It's easier to sell hot flux at GTFO than cold flux, so I heat it up. Now I'm going to try to do just inside the chip because around there is the nasty flux on this clamp. I don't want to spread the nasty flux from the clamp around my chip while I'm trying to clean the chip. We're just about there. After this, we're going to go over some of the most common mistakes that people are going to make when replacing the SMC. At least the ones that, I mean, this is an opinion, because ultimately the way that works is the way that works for you. So this is just my opinion, but these are what I consider, in my opinion, to be the common mistakes that people are going to make. So I'm just going to clean off the SMC chip itself. Okay. Nice try. Okay. So the first mistake people are going to make is to put the balls on. They're going to put this little chip inside this clamp. And then they're going to put the stencil on top of the chip, because they think that the chip itself has to be secured inside of the clamp, and then I'm just going to put the stencil on top of the chip. And you probably can do it that way. The problem is that it's going to create a gap between your stencil and this. And that gap is going to cause all sorts of misery. So once the ball drops, after the ball drops, it's going to be there, and it's going to move around and combine with other balls. Or if you're using solder paste instead of solder balls, you're going to make solder balls that are too big. It'll be different sizes than the other ones, and it'll be a complete effing nightmare. I might actually include a clip at the end of this of SMC reballing hell, just so that you can see, so you can feel better if you're one of those people who did something that caused it to be a complete mess. So I'm going to clean the stencil and clean the chip as best as I can. Just get rid of the remnants of junk around it. So what I do, and again, you can do it differently. This is personal preference. If I'm doing like a PCH or a CPU or a GPU, I will happily put that chip inside of the clamp. Then I will press the stencil on top of the chip. Here, fuck no. What I'm going to do is I'm going to attach the chip to this, because there's just no room for error. This is 0.2 or 0.3 millimeter balls. There is no room for this to not be absolutely, positively, 100% aligned. Anything else, and you'll have balls combining to form another ball. Who knows? If this fucks up in this video, you may even get to see on camera the balls combining to form other balls and all that miserable bullshit. So first thing to do is to get myself some heat-resistant tape, or it's known as Captain Tape. And I'm going to tape this directly to the stencil. So anyway, we're going to get to the part that I suck at, which is aligning anything to be straight. This is not my strong suit. Alright, so we're going to take the chip, put the tape on the chip. Alright. So this is the chip. This is the stencil. This is BS. This is real bullshit. I hate doing this so much. Like, stuff like this is what drives me to look for jobs in networking or security and system installation. I mean, this. Eventually you will line it up. Okay. And once you line it up, push down. Now we make sure that of course it fucking moved. It's always gonna move as you go to push the tape down. Why would anything stay where it's supposed to when this is... Why would I be able to buy this chip with balls on it? Why? Like, why make life easy when you can make life a living fucking hell and get away with it because you're Apple? I wouldn't make life easy for people. There's a little fiber in there. Mofo. Oh, and I just aligned it too. Let's see. Actually, that looks like a little dead bug, doesn't it? That's a little fiber. That's a fiber. That's a fiber from my ESD save paper towel. Bah. Alright, get rid of that. Is there a chance? And oh, hell no. It's laughing at the tweezer. It's like, are you kidding me? You think you're gonna move me through that? No way! Okay. Okay, you little prick. Yeah. Time's up. Get out of there. Let me put it back on. Let's move this microscope up so I have more room to work with my hands. I think that's pretty well aligned. So we tape it on there, we push the tape on there, then we make sure that it's still aligned, because that shit can change any second. Alright, now we tape it the other way around, because God knows it's going to try, that little piece of tape cannot be trusted. Cut off the excess tape. And of course, in making it neat, it misaligned. This is just bullshit. Okay, we're going to take another piece of tape. Go over it, because I know from experience that if you trust one piece of tape, it will troll you. It will make your life hell. Okay, I'm going to put the other piece of tape over here. It's aligned. Okay. So here's what I'm talking about when I say don't use the SMC clamp. So this is the kind of thing that has to be demonstrated on camera. So this over here has, might as well show it to you under the microscope. So you see how this is cut out for the SMC over here? This is cut out to fit the SMC perfectly. That's great. This here is really great when you're actually cleaning the SMC. This is good. This is not going to work now because I have tape over it so that I could tape it directly to the stencil. Since it's taped directly to the stencil, there's not going to be the indents over there for it. See, because it's covered in tape? So this is not going to work because that tape over here has a, you know, it's room. Like, it's not going to fit in the stencil properly. So here's what I'm going, it's not going to fit in the clamp properly. Make sure it's still aligned. It is, great. All right, so what I do is I put this aside, I'm done with this thing, and now I'm going to use a regular clamp, which I put over here. Alright. And I'm going to put it in this clamp. But I'm going to push it down very nice to make sure that it's not going to move around or anything. And of course, because I'm a paranoid freak, I'm going to make sure it's still aligned. I trust this shit as far as I can throw it. Which I shouldn't say that, because you could probably throw this thing pretty far. It's a tiny chip. Alright. Okay, then I'm going to put it inside of this clamp. This clamp pretty much just grabs the stencil. So I'm not grabbing the chip. I'm not grabbing the chip. I'm grabbing the stencil. Okay. Now, I'm going to take some solder paste. So I have a lot of different solder pastes here. Oh, by the way, this is another thing that's worth discussing. So solder paste versus solder balls. So you have two choices at this junction. You can put solder paste in there and use that to create solder balls, or you can just put solder balls in there. If you're working with a CPU with 0.75 millimeter balls, if you're working with a graphics chip that has 0.45 millimeter balls, just put balls in there. You put the balls in, you put it in the BGA machine, You bring the nozzle down and it heats the balls, and the balls melt onto the chip, and everything's fun. That's great. Now here's what's going to happen when you use solder balls on here. If you put solder balls in there, you're going to put a solder ball in each one of these individual holes, right? In each one of these individual holes, you're going to try to put a solder ball. First thing that's going to happen is, since they're so small, you're going to wind up getting 2 balls in one hole. So when you're running around with those balls and you're putting those balls into the holes for a CPU or a graphics chip, only 1 ball is going to fit in the hole. Over here, you can very easily fit 2 solder balls into one hole, or have a situation where one of the solder balls is sticking up out of the hole, and then you have to go and pick out each one of the fucking balls that fell into one of those holes. The second thing that's going to happen is that the ball itself is going to get excited. It's so excited that it's right about this to get soldered onto the SMC. It's so excited to be getting heated up that it's going to jump right out of the fucking hole. And the ball is going to jump out of the hole, and then it's going to melt over here. And it's going to be like it's going to be stuck in your stencil. It's not going to be soldered onto the fucking pad, and it's just a nightmare and a miserable mess. So what we do over here is I'm going to put some solder paste in here. I have a few solder paste to choose from, and I'm going to spread it on there. I'm going to get it into each hole. And it's not going to jump up like the solder balls do. And I also don't have to worry about putting too many balls in one hole. Whatever fits in the hole, and then I scrape away at the top of it so that only enough to fit in that hole is there. You don't have to worry about a ball stacking on top of another ball and sticking up out of here. I can't get rid of multiple balls in a hole by doing this, but I can easily get rid of excess solder paste by doing this. You may ask, if solder paste is so much easier, why don't you use it on a graphics chip, or why don't you use it on a CPU or any of those things if you're trying to put balls on one of those chips? The reason I don't use it on those is because it's harder to get the balls to be every single ball to be the exact same size. And since I don't have those problems in that scenario, it's just easier for me to not use solder paste. Solder paste, you have to make sure that each individual hole is filled up. And when you have larger holes to deal with, and when you have 900 balls versus 90 balls, that is a huge fucking pain in the ass. So pretty much with the different sizes, you're trading different types of pain in the ass. And what I find is with the smaller chipsets that I would rather have this pain in the ass than the other type of pain in the ass. So I have 2 different solder pastes here. I have Amtech. Let's see. This is Amtech 13791. That's a good leaded solder paste. And then I also have this stuff over here. This is Kester EP256 solder paste. I don't even remember buying these things, but I have them here in my drawer. And one of the things about solder paste, if you don't store it properly, if you don't refrigerate it or keep it at whatever temperature it's supposed to, you get, I would say, a month, 2 months before it's fucked up. So if you notice that you're trying to do this job and you're doing everything I'm doing and the solder paste is doing all sorts of things that you're not telling it to, then there's a good chance that your solder paste is fucked up. And I also saw this damn thing misaligned, so let me just fix that before I start. Better? I'm losing it. Okay. Put the chip into the clamp. And hopefully this thing works. Get it nice in there in the clamp. Okay, I take the solder paste. I want to inject this into every hole. I know. Laugh. Balls in every hole. And you can't see this under the microscope, which sucks, but is what it's seeing. I don't have space to do this the way I want. So I'm going to try to inject the solder paste into every set of holes. So I'm pushing down on the chip kind of hard, and then I'm pushing down on the syringe hammer hard, because I don't want to have the solder paste hover above the hole and not fill it. I want the solder paste to fully fill each one of those holes. And this stuff is cheap. You know, like 15, 20 bucks gets you a whole syringe, and this is not even buying in quantity, so feel free to use more. You're going to wipe the excess off later, and again, you want to fill every single hole. That's that. As soon as you're done with this shit, don't leave it open. Put it back in its syringe. I mean, it's container, so you put the cap back on there. Again, good work habits. Good work habits are going to keep your life from becoming a clusterfuck. And the biggest enemy of good electronics repair is when your life and your desk and your table and your mind are a clusterfuck. Because when this stuff starts to not work, it'll drive you nuts. Because you'll be trying to do a job and it won't work because your tools are not working. And then your tools are not working, so you can't get it done, so you get driven more nuts, and it's just this terrible, terrible spiral to hell. So I'm going to clean off my tweezer real quick here. Alrighty, some alcohol. Get rid of the excess alcohol in the end. Okay, and I'm going to wipe that paste into every single hole. Don't touch this stuff. This is filled with lead. Keep in mind what the purpose of solder paste is. The entire purpose of solder paste is this stuff is made to flow freely to the bottom of every single one of those holes. It's meant to seep into little places and get stuck in there. That is its fucking design. That is its intended purpose. So what do you think this does to the pores of your skin? And did I mention that it's made of lead? So yeah, don't touch this shit. Don't touch this stuff. I like having nice skin. I like not having lead in my bloodstream or inside of my skin or anything like that. Okay, so then we're gonna wipe off the excess. This is important because again, you make the ball too big, it'll stick up through the stencil. You won't be able to get the SMC out of the stencil. You will rip the pads off of the SMC, and the SMC will be fucked. And that's no good. So take your time in getting rid of any bit of excess. I wipe away and I wipe away until I can make 2 or 3 wipes and my paper towel is still white and not have any bit of gray. Get rid of that excess shit. A bigger ball is much worse than a smaller ball. It's best to have no error at all, but if you are to have an error, a ball that is too small is much better than a ball that is too big. Keep in mind, all these balls are going to be dropping anyway. So now I'm going to put my Hakko FR-801 with the 4mm nozzle to about a heat of 6. I'm going to turn the air all the way down to like 9 or 10. And the reason for that is that I don't want the balls to jump out. So I'm going to heat them slowly. The balls are going to get heated nice and slowly. The whole idea here is if I run in and jump in on there immediately, that what's going to happen is it's going to get excited, and that solder paste is going to explode out through the stencil, and you'll see that every single one of those there's 2 things that can happen. Either the solder paste just slowly kind of turns like a sphere just turning, and it just rolls over and sits down like a nice little solder ball, or it jumps up excited and turns into a ball that combines with other balls, and we're trying to avoid the second one from happening. So I'm going to preheat it first because again, I don't want to get it hot too fast. I don't want to excite the stupid solder paste. Because I'm telling you, it's going to look easy when I do it now, but you'll see when the fucking balls jump out and combine and form other balls. It's the most frustrating shit in the world. So take your fucking time. See, one of them is trying it right now. You see that shit is trying to jump out and turn into another fucking ball. On the right. We're going to give it a chance to correct itself. And there's another one that... Oh... Okay, so you can see what I'm talking about, right? Like that ball over here. Okay, let's see how this came out. So can I remove this, or is it a mess? Alright, so I fucked it up a little bit. You're gonna see how I fixed the fuck up a little bit. That is a joke. Alright, so that didn't go the way I wanted it to at all. Try again. That was awful. So some of the balls were too big. The result wouldn't allow it to leave the stencil. So we try again. Where's my other clamp? Other clamp is over here. One saving grace here being that this is leaded solder paste, as I don't have to run over it and tin every pad again. Try to scare me into thinking that you're a broken pad. Freaking SMC. I hate SMCs, man. Hmm. clean the chip. You may wonder why I don't use flux on there. Putting flux under there is a great way to get it all to get the balls to start jumping out of the holes, because the flux is going to kind of bubble a little when it gets hot. Okay, now we still have all those balls in the stencil. Hot air at max air is going to get rid of that very quickly. We clean the stencil off with some alcohol. Okay, now let's try that entire process again. Again, like, it's probably not smart for my business or my image to upload videos of SMC reballs that go fucked up. But the thing is, I really feel like what you're going to learn from is not just what to do, but also what not to do. And I feel like a big confidence builder is when you see that somebody who's done it a million times, who knows what they're doing, also encounters the same mistakes as you. There's nothing that's really more discouraging than watching somebody do this job that is just so absolutely perfect, without flaws, and then you doing it yourself and it going the exact opposite. Like, I feel what's going to help you is you seeing all this stuff mess up, and then realizing, oh, it happens to everybody. Which is why I strongly believe in not editing the screw-ups out of these videos. So, because it would be really easy to just edit fuck-ups out of them and, you know, make myself look like a genius that just never made a mistake in his life. But how boring would that be? What kind of inspiration would that be to you? It would just make me want to give up. Alright, let's try this shit again. Okay, gonna go like this. This is a royal pain in the ass. Yeah, aligning things is not my strong suit. I could never put a clock on the wall straight or hang a painting straight or... like... After a while of doing this, you just start to want to pass out. Okay. Now stay. So the little bit of moving of my finger that I did to actually get the thing taped on properly was just enough to totally misalign the fucking chip. Like, where is the science in this? Where is the analytical thinking? Where is the fun in this fucking cruel? This is bullshit. This is really bullshit. This is not fun. This is just horse shit. Fuck Apple for forcing people to do this. Seriously. Fuck Apple in the ass for forcing me to do this. Because you don't want to make programming of this available, because you don't want to sell these things to people. There's no fucking need for this other than just spite. That's what it is. It's just spite. Like, fuck you people who want to repair our products. Like, you can all eat it. We don't give a flying fuck about you. We're going to make this shit as miserable as humanly possible, and we're going to laugh at you when you try to fix it. It's bullshit. Alright, so let's get this thing going. Is it aligned? It's aligned. Let's go. Alright. Get the big clamp. Gonna get the big clamp. I left the big clamp right in front of me and I didn't see it because I'm losing my mind. Okay. I'm gonna get the stencil into the big clamp, make sure it's nice and secure in there. Get my solder paste. And we're gonna try this shit again. Alright. At this point, I'm satisfied that there is solder paste in every hole. Now to get rid of any excess. Getting rid of the excess is very important. If you don't get rid of the excess, what happened 20 minutes ago will just happen again. One of the things that may actually help with getting rid of the excess is tighten the clamp a little bit, push down on the middle of it, and then wipe around the chip. This is actually something that I usually do that for some reason I forgot to do last time. Because this stencil, this shit is not flat. Like, you can get, you think it's flat, but you just look at it, even if you just bought it and you think it's flat when you get it, it's not. So you push it down a little bit onto the chip, and then the excess will pop out if you have any excess on there. So this is a good way to get rid of the excess, which I really don't understand why I forgot 10 minutes ago. We're just going to turn this thing around. Right now. It's a nice song off of Van Halen's live album. See, when it's pushed down flat, there's going to be less space between the stencil and the chip, which means less space for solder paste, which means less solder paste in each one of these. So just get... Okay. Now let's hope that that goes better. So I'm going to have the heat on this thing turned up to about 6.5. And again, I don't want these balls to jump, so I'm going to put the air down to 6 now, which is almost no air at all. I'm going to preheat it. I'm going to take my nice sweet time with it, because again, the more time you spend preheating, the less chance of balls jumping and combining and turning into other balls. And I'm going to preheat from further away. I'm going to give myself a good minute with the preheating. Yeah, it started to melt a little bit. I didn't give it a full minute of preheating. But hell, I'll go with it. The left side is scaring me. Do you see why the left side is scaring me? I have no idea what happened there. I'm afraid to find out. But what are you gonna do? Let's take this thing off and see what happened. Get rid of the tape. That looks like a mess. That looks like a total mess. Yeah, fuck that. I don't know what that is, but that is not usable. So we go for try number 3. What happens if I put the... You know how I always say that when I try to do things in a video, how it never works out the way it does in real life? What happens if I actually just put the stencil over the clamp over here? Just for the hell of it. Because that never works in real life, but maybe it'll work in a video. Because a lot of the things that work in real life don't work in a video, so I'm kind of curious if that rule works the other way around. Like, will something that works, that doesn't work in real life, work just because I'm trying to record it? It would be hard for this to go any worse than it already is, so let's just try it this way. That pin, it's still got some... Blah. Get out of there. Oh boy. It's about time to get home and go to sleep. I don't know why I always put the videos at the end of the day. I was thinking about changing this and actually putting the videos at the beginning of the day. Because by the end of the day, I don't want to, I don't know, I just kind of lack the inclination to fix anything. And so I'm kind of recording me when I don't actually want to be working. Which is not exactly the best plan for creating inspired video content. Okay, so let's see if this actually winds up working out differently. So, let's see just how much God wants me to be wrong on camera. Let's see. I'm an agnostic person, but I do believe that there is some sort of God that likes to make me look like an idiot on YouTube. Let's give this another try. Stupid cable. My cable is tangled around the chair. And I'm sitting on it. Okay, now I do the push down. All that excess can GTFO. Turn the clamp. Push. Turn the clamp. Push. Turn the clamp. Push. Alright. Is the hot air station ready to melt solder? Sure is. Nice try. Wouldn't that be great? How did I miss that? It is time to go home and go to sleep. Yep. Okay, ready to go. Got the air at 9.5 and the heat at 6.5. I'm avoiding all my usual precautions because, let's face it, none of them actually have worked anyway. Goodbye, fiber. You piece of shit. You fucking... Alright, we're gonna get that one later. And there's another ball there that needs the GTFO. You see the one I'm talking about? This one over here. This ball can suck it. Okay. Now the ones that are a little messed up, I kind of want to get them to form into a proper ball. So I'm going to try to do that by getting some flux on there. This is way too much. But I don't have my syringe with me, so... oh well. One of those balls I'm going to have to place manually. The one that popped out. Okay. There's really no way around touching the tape that's filled with fluxes there. Okay, just making sure. Let's see what we have. Now. I'm going to take this below a solder melting temperature at around 3.5. Let's see if I can get this off. Alright, let's see what this looks like. It's either going to look good or a complete mess. Keep in mind, this entire process is being undertaken on a chip that came off of a dead motherboard. I did one earlier today that wasn't on camera that went pretty well. Like, better than this at least. Something about turning the camera on that makes all the repairs go to shit. Okay. Dude, this actually has hope. All I gotta do is put that one ball on there and I'm good. So this is where having the little portable solder balls is cool. So I don't like pouring these solder balls in there. Whoa, I just sprayed a bunch on the floor. Whoa, 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 whoa. Okay. Alright. That's gonna be a nightmare to clean up. My floor is now filled with lead. Alright, I'm gonna pick one single ball out of here. Place that single ball. Fuck, who am I kidding? That ran away into the 6th dimension very quickly. And take that one single ball. Put it right here. Who am I kidding? Again, gravity, this is the other thing that sucks about using individual balls. Gravity is no longer gravity when you're dealing with shit that's this tiny. Like, okay, drop because there's gravity. No. No. Good. No, there is no fucking gravity. So what works is putting... The only way you're going to do this is by getting some flux in there. Because then the ball is going to stick into the flux. See how that works? And I also might as well put some flux on there so that all the balls that are not really nice looking can get reshaped while the hot air is on them. That's way too much flux, but who cares? The time to care about such things ended about an hour ago. Okay, so we put the heat on the iron to about 6.5. Airflow to about 9. Wait for it to heat up. Might as well just preheat in the meantime. So I got too much flux on there anyway. Nice try. You wanted to go over there and become another ball, didn't you? No, fuck you. Nice try, little ball. Melt. Melt. Fuck you. You're already attached. Oh, you shit. You combined and turned into another ball. Okay. Now I got two to put in there. That's great. That's great. That's hilarious. Okay. Alright, let's grab two now. I'm gonna do this one at a time. One ball. Okay, we're gonna melt that one ball on there. Zoom in on that mofo. Target. Haha, you've dropped. Now I gotta do the other one. Before I do that, let's wash that huge gunk of flux I just got off my hands. Okay. Let's grab the next ball. The next individual solder ball. Okay. And heat that little thing up. Drop. Don't make a run for it. You made a run for it, you little shit. Drop. Let's zoom out so that I can see where my iron is. And awesome, it's on there. Okay, now I'm just gonna run over the rest of the balls. The air up a little higher. Are you whistling because you like my balls? Okay. Listen, this ain't getting any better, so here goes nothing. Whoa, this paper towel is way worse than the last set that I had. Ugh. Yeah. Okay. Here we go. Again. This really is, for me, about as good as it's going to get. This is not getting any better. Viniera, you were on camera. I can try and remember to delete you, but since I edit these videos at 1 in the morning, I'll probably forget. I'm going to just brush my chip off in the ultrasonic cleaner really quickly. And we'll get to soldering it onto the board. Ultrasonic is sizzling. Toothbrush some of the junk. Okay. Run it through the alcohol. And onto a paper towel. It's my chip right here. My beautiful chip. Okay, motherboard needing an SMC. What else could possibly be wrong with this board? What else could possibly need to be done to this motherboard? Oh my god, this is a clusterfuck. This is yeah, this is some bullshit. Okay. Sometimes I take on things just kind of as a challenge. Like this one guy sent boards that his techs fucked to shit, and they actually required wires being run underneath the SMC. So you'll notice there's one pad that's ripped. It's a ground pad. Not something to be all up in arms about, because it's just a ground pad. There are many other ground pads. So we're gonna do our best to align this damn thing. And alright, so let's get some flux on it. Here it really does matter if you put too much, because then the chip will bubble and bounce around more than it's supposed to. So after I put my flux mess on there, I'm going to wipe the excess off. I really need to get a clean room wipe for this. That's the thing, these paper towels used to actually be good. They used to not leave fibers. I either cheaped out and I bought a different one or something. What the fuck? I mean, I can't really see much under the chip, which is the important part. Like what you see, it's... Wow. I guess this may be surprising, but the consistency in fibers and cheap paper towels is not what you would think. But anyway. There's no fibers under the SMC, which is really all I care about. Okay. Now to check another one of these that I did because I actually forgot the orientation. So the other 3115 SMC that I did was... which... Yep. Facing to the right. So let's take the chip. Here goes nothing. The flux is really reflective. By the way, Apple, thank you for marking the board so I know where to put the chip. Thanks a lot, guys. I really appreciate that you put those little L-shaped brackets on every corner so that I know exactly where to put it, so that I know that I'm aligning it the way it was originally. Thanks a lot, Apple engineers, for putting that little effort in to make my life easier. You know what I could do? I could actually look at a board that has the chip soldered on. Let's see, where's it? Where's one that I haven't fucked with? 3115 with the... Here we go. And let's see what the distance is, so we can get an idea of the alignment. There's that much space from each resistor on this one, and... So right at those two holes, So those two holes. On the left side, it's going over those two holes. On the top side, it's like right at the edge of those two holes. Let's see where I am over here. Why am I still holding this? Am I nuts? Try that again. Okay. On the top side, it goes right to the two holes. And on the left side, it goes over the hole. Push down so that it's situated on the pads. Pray to the BGA God. Time for soldering. This is where you really just pray. This is a huge chip, so this will take a while. Also, there's a lot of flux there, so more fume extraction. Just pretend it's a really big LED driver. Heat away all the excess flux. Oh, it just moved into place. You saw that? It just moved into place. That's beautiful. But it's a big chip, and there's center balls that may not be melted yet, which is why I heat it more so I can see it move back and forth. Move for me, SMC. That's right. Move back and forth for me. So you've been moving back and forth for about 10 seconds now, which means that I'm done. I'm heading out of there with the heat. And the SMC is on the board. I don't really want to mess with it and make, but the balls are really small and there's not a lot of them, so I'm gonna say after about 10-15 seconds it's dry. Just to cool it off a little bit. Right. Let's see what that looks like under the microscope. Fuck you, air filter. Fuck you, Hakko. Turn off. There's a damn near microscopic chance that this shit actually works. Come out, microscope. Okay, let's look at you under here. This may actually work. I mean, I don't know. I mean, the SMC soldering job, I mean, not the board. The board is a... You saw what the board looked like. This board is has very little hope of ever working again. This is one of those boards where I just kind of took it on as just a challenge project because I don't know why. Like, in normal... by my normal rule, I would have tossed this shit in the garbage a long time ago. So let's see what happens. So before I had no green light on the charger, and now what do I get? Do I get anything? Holy shit. I got a green light in the charger. Pretty cool. So I didn't have a green light in the charger before. Now I'm going to get greedy. Now I'm going to do something that I probably shouldn't do at the end of the day after being here all day. I'm going to push my luck a little bit, and I'm going to see if the fan spins. And if this is God's way of saying don't do this, so the fan wire actually broke. Oh, man. let's grab a fan. Where's a fan? Quick. My test fan wire died. Here we go. Here's a fan for one of the machines I need to refurbish for the window. Again, I'm getting a little crazy here. I shouldn't expect much out of this piece of shit. But do I have the fan spinning? Holy crap. What? Fuck yeah! Okay, the fan spins. Now, am I going to test the rest of this right now? No. I'm going home. Let me explain. Look at this. Let me just show you. Let me show you how much work there is left on this little challenge pile of shit. So again, just to give you a recap, this board originally did this. We had this going on. We got this going on, and look at the backlight section of this. Look at the fuse. Not only is there no fuse, I didn't remove that, by the way. There's no pads, and there's no fuse. Not just the fuse is blown, but this thing is just fucked. Man, I'm kind of tempted to continue. I really should go home. Like, if I had half a fucking brain, I would go home. But let's see what we can do. Let's see. Alright, so the LED driver, oh my god. Okay, that needs replacing. This board needs to just go in the trash. Alright, but fuck it. Just since I spent so much time on it already. Yeah, look at that nice LED driver. Oh. Oh. Disgusting. Fucking disgusting. Alright. Get up there. Okay, so we're gonna have some work to do here. First, let's see if the pad is gone. The pad may not be gone. That's the thing you gotta think about. The pad may not be gone. It may just be covered under oxidation and bullshit. But it may not be gone. I only have 62 gigabytes free, so I actually probably should cut the video because I'm almost out of space. But, I'm not good at this. Nah. Actually, I can delete a video from yesterday that's 71 gigs. That'll give me some space to keep going. Let's do that. Empty bin. And now I got 128 gigs. I don't know if 128 gigs is going to be enough for a board that looks this bad, but let's see. First thing to do is there's one pad. Oh boy. And the other one? Whoa, there's like a kind of a crescent moon-shaped shit stain of a pad. Let's keep going. Yeah, so the reason I changed the SMC on this is because all conditions were present for it to have a green light, but I had no green light. Okay, we'll go back to the backlight fuse later. Let's just get that LED driver lifted. Man, I really should go home. I don't know what the fuck I'm doing working on this board. Yuck. Ugh. Eck. I'm not going to wick the pads like you should with an LED driver replacement because I'm fairly certain that they're being held on the board by shit. I'm making an executive decision there to not do anything on those pads. Okay. Let's get an LED driver on there. Let's remember the orientation. I hope that's the orientation. I feel like I may have forgotten the orientation. Oh God. I'm turning into Sunny. Okay. Melt, you fuck. I had it sitting too high. See, I didn't push it down, which is wrong. But I got the chip to dance, which means it's on there. Now for backlight fuse. I hope that feedback V isn't destroyed. Oh, you're good. Feedback V is good. Okay, now what am I gonna do about this bullshit? Like, I'm supposed to solder a fuse to this? Really? That's bullshit. Oh. What's another wire on a board that probably has 6 or 7 of them already? Alright, we're gonna put a fuse there. I'm gonna see where else I can grab that point and we'll just run a wire. No big deal. Wouldn't it be funny if that little shit stain of a pad was actually enough to carry backlight? I mean, that's obvious. That's a very wishful thinking, but it would be funny, wouldn't it? I can't help myself. The curiosity is killing me. I need to know. Also, the flux on this tweezer is complete garbage at this point. Let's just clean that off. Okay. Okay, I gotta know. I mean, I gotta run a wire anyway, because I'm not putting this board back into the world being held together by shit. But I still want to know. Okay, so what do I need? So firstly, reballing is done. And when you're done with a tool, put it back, put it away. Even if you don't put it where you're necessarily supposed to be, just get it out of being right in front of you. Not drinking that anymore. 2 solder balls over there. Thermal paste over here. This there. Over here. My fan. First, let's see if there's a short to ground on backlight output. Like, needless to say, on this board that looks like this, that's really something to check. See how much space I have left on the recording drive. 104 gigs. All right, so I'm good. Okay, let's. So for backlight output, dude, I'm reading what I'm supposed to. Okay, not exactly what I'm supposed to, but much closer than what I thought I would get. All right, I got a RAM stick. All that's necessary now is a screen, and let's see if I get a picture. I mean, dude, what do you... There's no chance. Do I actually have CPU V-core on a board that looks like this? I haven't checked the CPU V-core area. Oh, those resistors are... Who am I kidding? Let's see. Am I going to get CPU V-core on a board that looks like this? Because if that's what happened to PP Bus G3 Hot at the backlight area, what happened to PP Bus G3 Hot at the CPU V-core area by the CPU IMVP ton resistors? That's going to be destroyed. Alright, yeah. But let's see. One step at a time. Fan spins. Do I get anything? Okay, now I'm just kind of being Icarus. Trying to fly too close to the sun. The screen doesn't even activate, which means no CPU V-core most likely. Okay. Can't have everything. Let's see. Let's open this. Well, shut up, air filter. Go back to low. Alright. Okay, let's open the board view for this board and continue. Man, wouldn't this be cool if I can actually get this piece of shit to work? Because you saw what this thing looked like. This looks like cock and balls. This really needs to be given up on. Alright, so U7400. U7400. So R7403, R7402. Where are you? You're over here. Okay, what do you guys measure? So these need to be present and working for the CPU buck regulator controller to know the switching frequency to get from whatever the source voltage is to whatever voltage it wants to make the CPU V-core be. The problem is if it doesn't know what that is, then you get nothing. And those resistors are totally fine. Let's see if I have CPU V-core. PPV core underscore SO underscore CPU. Where do I find that? I find this over here. Okay, let's measure. Turn the thing on again. Let's see if I have that. Maybe I'm just really tired and I'm mistaking no backlight for no image. Okay, fan spins. Voltage on CPU V-core is 1.1. Okay. Let's see, what does image look like? Does the screen activate? Not at all. Let's see what the LCD connector area looks like. The LCD connector area actually kind of looks fine. So CPU V-core comes on. Let's check the U9000 area. Let's see if it's telling the LCD to come on. That'll tell me if it detects the LCD. So which one of these is U9000? Not you, not you. You? Not even close. Are you U9000? No, you're U9000. Alright, so on pin 1 over here, LCD, IG, power, enable. So when I plug the LCD in, let's see if I get anything on there. Does the computer even know that a screen is connected? I should actually plug in a speaker. I mean, for all I know, this board is beeping at me that it can't see the RAM. Or the RAM is bad, or there's no RAM slot that works. So let's find a speaker. This is a speaker here. You want to hear a dong. You want to hear a nice long dong. Everybody wants to have a nice long dong. It's beeping. See? I'm being a fucking idiot. This is what speaker is for. Okay, grab this RAM stick from the machine I need to refurbish for the window. And plug you in. Are you still going to beep at me? Still beeps. Maybe it's a bad RAM slot. Let's try the bottom RAM slot. Let's face it, one bad RAM slot on a board that looks like this is expected. And this board has what is most likely a dead CPU or a dead PCH, which means it can rest in peace. Which means that this entire effort was kind of a waste of time. But the point is, at the very least, you get to see that the SMC replacement worked, because before, not only did you not get a green light, you also didn't actually have the board turning on. Now, it turns on, it has a green light, there's no quarter fan spin, but it's just a fucked piece of shit. And I'm not replacing the CPU on this board. I'm not going to replace the PCH. I'm not doing any of that. This board has had its time, and it is done. But at the very least, I got to go through the entire process with you. And again, why do I not like SMC replacements? Because all the boards that I get where I know in my heart that what I have to do is replace the SMC. All the boards that I get that need an SMC, they're clusterfucks like this. Like, you know, again, you can see that even if you're really good at this, even if you are 10 times better than me and your first SMC reball works, you have to find it off a board that doesn't work. You have to take that SMC and, you know, you have to prepare it, and then you have to solder it on, which is kind of a pain in the ass. And all of this is being done on a board where you don't know if it's going to work after, and you're taking that SMC from a board that you don't know if it worked to begin with. So this is why I hate replacing the SMC on a MacBook motherboard. This is why I put those repairs usually closer to the bottom of the pile. And hopefully you learn something. Hopefully you learn from all the silly, nonsense, asinine bullshit mistakes that I made. And honestly, I'm kind of glad that every single kind of mistake happened in one video. So you had the mistake of balls combining to become a bigger ball. You had the mistake of balls jumping out. You had the mistake of misalignment. I mean, you had literally almost every single mistake that you could make when reballing an SMC to put it back on here. Every single type of mistake that you can imagine happened in this video. So one of the things I say about learning, you're not only learning how to do something, you're also learning how not to do something. So if these videos help teach you how not to do certain things or how not to make these mistakes, I'm actually happy. This board is going back to the person who sent it to me. And again, this is the thing about board repair. People go like, why is it so much money? Why is it that, you know, why is it $325 to fix my $2,500 laptop? The thing is, again, no fix, no fee. Like, how much time do you think went into this whole thing? Because I'm not even just talking SMC. Let's talk about, you know, all of this stuff going on over here. Like, how much time do you think all this shit took? Like, really, to get this thing to the point where it would actually function. You know, this took time. All of this takes time, and that is time that I can't get back. And that is also time that under my current billing model that I cannot charge for. So since I can't charge for any of this, what I am going to do is I'm going to charge a rate for the stuff that I can do. And you can think that it's mean, you can think that I'm being an asshole, but it's a market price. I mean, you know, again, there are no shortage, absolutely no shortage of Mac laptop repair places in Manhattan that you can go to, and 99% of them don't do this. They tell you, "I'm sorry, this board is $375 on eBay. We want $100 to put it in your laptop after tax. You pay $550. $325, I feel, is completely, totally fair, and it really does cover moments like this where I spent over an hour on a board that, at least maybe 2 hours on a board that I can bill $0 for. So that is the no fix, no fee model, and it works for me. So I'm just out of sheer curiosity. I want to see if I get an orange light, because if this actually sees the battery and can charge it, then that would just be a miracle. I know, a complete waste of time because it has a dead CPU, but wow. See what the orange means? It means that not only does it see the battery, but it can fucking charge the battery. And there, you know why I'm interested in that. If you know what those wires do down there, if you know what all those wires do, then you know why I'm interested in seeing that it charges the battery. This board is a fucking masterpiece. I almost kind of, I almost want to replace the CPU on it, and the piece or the PCH or whatever is causing that ridiculous bullshit. But no, time to fucking go home. Good night.